So what happens when you mix up these funny looking flags and a quirky RPG battle system? You get something like this. Hello everyone. Today I'm going to take a look at the Factor programming language. Factor is quite different language from the ones I've already seen. That's because this is a concatenative stack-based programming language. And what is a stack-based programming language? Well, according to concatenative.org, in concatenative programming languages, things are evaluated by composing several functions which all operate on a single piece of data, based from function to function. This piece of data is usually in the form of a stack. So this will be easier to understand in the factor listener, which is sort of like the factor REPL. So let's take a look. See, in applicative languages like PHP or any modern programming language, if you want to do 2 plus 2, you will write it like this. In Factor, however, it uses something called reverse Polish notation. So you will write this like this. First, you have to push 2 to the stack, then you have to push 2 again, but instead I'm going to call something called loop, which is a word or a name function which has a stack effect. This word takes one value from the stack and returns 2 values, which is the same value 2 times. So it duplicates this value. So now that I have 2 and 2, I have to call plus word, which also has a stack effect. It takes these 2 values and returns the sum of 2 and 2. And as you can see, it works pretty well. So this will be written like this: 2, 2, and plus. So there are different words to move things or add or remove things from the stack, which I'll call shuffle words. For example, we can push 5 and then we can swap these 2 values, 4 and 5, with the swap word. And well, there are many different shuffle words. We can drop and well, many others. Now here's something that makes this language unique. For example, if I write hello and then I call print, as you can see here, it executes this print right away. But if I put this between square brackets, for example, this, you can see here it didn't print hello. So instead what it did is create something called a quotation. A quotation is like an anonymous function, which is a piece of code which is added to the stack. So this was not executed yet. There are different words which takes quotations and can do many different things with them. For example, if we want to execute this quotation, we will call the word call. And as you can see here, it printed this string. So there are a lot of words which take quotations as arguments, and those are called combinators. So for example, we can, if we want to do an if, we can do it like this. First, we need a boolean. For example, let's say we want to check if 2 and 3 are equal. So this equal returns a boolean that checks if these 2 numbers are equal. So now we have to create a quotation which will be executed if this condition is true. And now I have to add the second quotation which will be executed if this quotation is false. And finally, I have to add the if combinator that will take all of these and will execute it accordingly to this condition. And well, as you can see here, it works. So there are many different combinators. For example, if we want to do a for loop, we will do it like this. First, we have to push the number we want to iterate, for example, 16. Then we create the quotation, which Let's say, for example, we want to print the binary expression of the numbers. So we will write dot p. And then we will execute each integer. So what this word does is it executes this quotation from 0 and it passes the value 0 to 15. So in this quotation, we'll print that value in a binary form. So as you can see here, it works very well. It prints number from 0 to 1111, which is 15. Now, there's one more thing I want to show you before jumping to the game's code. Let's say we want to create my own word or function that makes the square of any number. So colon is to say to factor we want to create a word. Here's the name. Here's the name of the word. And here's the stack effect. We want to take one value and return that same number but square. The names here are really not important. You can put whatever garbage you want here. This is just to say that to factor that this word will take one value and return also one value. So what we want to do is we want to first duplicate this value, so we call dup, and then we want to do n times n. So we will cut the times word. And then we add a semicolon to finish the definition of this word. So for example, if you want to do 2 squared, it returns 4. And we can also call square on that result. And as you can see, it works pretty well. Now, in stack-based language like Factor, you have to keep track of the contents of the stack, variables, their position, and when you're doing something not so trivial, the code can get a bit complex, especially if you're not experiencing with these kind of languages. That can be fixed by using something called lexical variables or locals. So check out this example. So 2 colons means that this word will take name inputs. So now the name of these parameters are important. So let's say we want to create a test word which will take one value and return nothing. So for example, let's say we want to create one local variable and we want to set to it a plus 1. So we will write a1 plus, so we have a plus 1, and we set it to a local variable called none. So now we add that local variable to the stack. And let's say we want to make a loop that will go to 0 from this number, minus 1, and will print even or odd, depending if the number is even or odd. So here in this quotation, we can also create in this quotation one named variable like this. For example, we have I, which is like a for loop. We usually use y. We add here each integer, which will turn this I from 0 to num minus 1. And here, we're going to do I to want the module from this value, and we want to check if it is equal to 0. If it is, then this number is 0. Otherwise, it's odd. And we add the if. And let's not forget to end this word with a semicolon. Okay, so let's say we want to check the number from 0 to 15 with this number that just happens to be on the stack. So we will call test, and as you can see, it prints from 0 to 15 all of the numbers, and if whether they are even or odd. And as you can see, it works very well. Of course, this is a very dumb example, which is it is possible to do without local variables. You will see in the game's code that I pretty much use local variables in the entire code base because it just made things way easier for me. Okay, let's take a look at the game's code. So here you can use or using to import different modules. In this case, I'm just using the game module, which is a different file. In defines the name of this particular module, which is called flagware2. And then main defines the main entry point of this code when I build the game. So when I build this, factor is going to look for this function to execute, and what this function does is execute the main function, which initializes the game, calls the main game loop, and then unlocks the game when the user wants to quit. So let's take a look at the game script. So here I'm using different modules which contain different factor features. Here's how you define the constant values, which are the red and yellow color, which are two structures which contain the RGB and the alpha values. I didn't mention before, but I'm using Rayleigh to create the game, which is a C library that I use in my past videos. So here's how I initialize the game. I create the window, I set the FPS, and initialize the different variables. The draw background, I simply set the background to red and draw a yellow triangle. So here's one way to create different object, like in this case, this is a C structure. You pass the two parameters and call the structure with angle brackets. So here I set the 3 points of this triangle. And here's the main game loop. You can see here, the entire code is inside one big quotation with loop. What this does is executes the quotation and checks for this condition. So here in the main game loop, first we check if the player is alive. Player is a symbol which is defined in the player code. Here, a symbol is like a dynamic variable. So in this symbol, I say this tuple will contain the different variables. One of them is the HP of the player. So first, I push the player symbol to the stack, and then I extract the HP, and I check if it is bigger than 0. If it is, execute this quotation. So it updates the boss, and here I check if the boss, which is a different symbol, is alive, or if this variable attack action done is false. If any of these is true, I update the menu. Otherwise, the boss HP is 0 or negative, so what I do is I check if the alpha value of the boss is bigger than 0, and if it is, I decrease it by 1. You can see here I'm using the when word, which is very similar to if. What when does is it checks for this condition is true, and if it is, it executes the quotation. Otherwise, it does nothing. So if the player HP is 0 or negative, I decrease the alpha value, same as the boss. Here, this is the drawing part, which I draw the boss, the menu with the different parameters. Here I check if the player HP is 0 or the boss HP is 0. I print this to the screen. And that's basically the main game loop. And here I unload the game. Well, as I mentioned before, this is the player symbol, a dynamic variable. I can store anything here. The tuple will contain the different variables, and this is the constructor of this tuple. This constructor could be a function which you can add logic before creating this tuple, but in this case I'm just creating the tuple and nothing more. And we have a constant for the player speed. Here is a different way to create a structure. This is called the boa constructor. First, I have to push the different parameters in order to the stack. Then I pass the type of the variable I want to create and call boa. So this rectangle, this is the x value of this rectangle, the y, and the width and the height. These are the two ways to create different objects like tuples or structures. And here I set the player symbol to this tuple. So here's the player movement code. As you can see here, this parameter has a exclamation mark. This means that this variable is mutable, which means we can change its contents. This variable doesn't have a exclamation mark, which means it is immutable. So we can change its contents. Same thing with these local variables. So as you can see here, I'm creating a new angle variable and a movement variable, which is a vector. And here I check which key the user press. So if the user press the key A or the arrow key left, I set the new angle to pi/2 negative and the movement to the x value of this movement to the player speed negative. And the same thing with the other different keys. Here I normalize the vector of the movement vector by getting the x value of the movement squared plus the y value squared, and I take the square root of all of that and save it in the magnitude variable. So here I check if the x movement is different than 0 because I'm using the unless word. Unless, check if this condition is false, execute this quotation. And the same thing with the y movement. And here I move the hitbox of the player. Well, the update function simply push the player symbol to the stack, change the angle because the player is constantly rotating, and call the player movement function. And well, here I draw the player with this relief function called draw texture pro with the different parameters. Well, I don't want to make this video any longer, so I'm going to explain one more feature, which I think is really cool. Here is the button script where I create the different buttons. Here I'm using something that is not defined inside factor, but is defined in this script called index. So what this does is it creates three constants which contains 0, 1, and 2. This is sort of like an enumerator. Factor contains enumerators, but the problem with the enumerator that I found is that, for example, I have these different buttons inside a sequence. So first I have to push the button sequence to the stack, and then I have to push the position, the index that I want to extract the button. For example, the first index is the button attack, so I have to push button attack. But the problem is that I can use this variable as it because first I have to cast it to an integer like this, and then I can nth to extract the button from the sequence. So every time I wanted to index a button, I have to convert the numerator to an integer, and that was very annoying. So instead of using enumerators, I'm using this index values, which is defined in here in this file. As you can see here, in factors, you can create different parsing words where you can define your own syntax. So in this case, you have index and plus index. So what this does is execute the create indices, which simply iterate. So it loops through each token, which are, if I'm not mistaken, are these different tokens. And it simply creates a word and defines a constant with the number that started. In this case, index by itself starts at 0, and plus index starts at an arbitrary number. So it defines a constant and then add 1 to the value of that constant, and that's pretty much it. And that's how you create different constant by simply defining the index syntax. And well, that's pretty much it about the code. There are other different scripts that I didn't show. For example, the menu, which is the longest script. The code is not elegant. It's actually very ugly. For example, well, you can see here in this comment. This is one way to create a switch loop. So what con does is it checks for these conditions and executes the one that is true. The first one that returns true. So if n is 0, then this will be true, so it executes this quotation. If n is 1, execute this quotation, and so on. You can add a quotation that will be the default value in case none of these conditions are true. So here you can put whatever you want in case none of these conditions are true. So, well, that's pretty much all about the code. Thank you for watching.